Let us differentiate this. Y equals to cos of inverse log of ex. Y equals to sine of cos of inverse log of e to the power x. Okay, so you will assume e to the power x as t, say t equals to e to the power x. Okay, then this will become log of t. You will assume log of t as, you will assume say log of t as s. S is equal to log of t. Now this will become cos of inverse s. You will assume cos of inverse s as w. So w is equal to cos of inverse s, and this entire thing will become then sine of w. Okay, so this is y equals to sine of w. Well, let me write this in the different ink for you. So it is y equals to sine of w. So from here what we can find out? Dy by dw. From here what we can find out? Dw by ds. From here what we can find out? ds by dt. And from here dt by dx. Okay, so what you can write is dy by dx is equal to the product of dy by dw, dw by ds, ds by dt, and dt by dx. Okay, so now you can write this. What is dt by dx? Just e to the power x. What is ds by dt? 1 upon t. What is dw by ds? It is minus 1 upon root of 1 minus x square. And what is dy by dw? Cos of w. Okay, this is cos of w. So you can write all this here. In place of dy by dw, you can write cos of w. dw by ds is minus 1 upon root of 1 minus s square. I'm so sorry. This is 1 minus s square. ds by dt is 1 upon t, and dt by dx is e to the power x. So now you can write this as, in place of t, you can write e to the power x. So this would become 1 upon e to the power x. Okay. Here, in place of s, you can write log of t minus root of 1 minus log of t square. And in place of cos w, you can write, cos of inverse s. Okay, let me simplify it more. You will have cos of inverse s. This could be written as simply as s, and in place of t, you can write 1 minus log of e to the power x square, and this will cancel. So what you will have is minus s upon root of 1 minus log of e to the power x. Okay, and what is s basically? Log of t. What is t basically? E to the power x. So it is e to the power x. This minus sign here. This is 1 minus log of e to the power x whole square. So this is a simple application of chain rule, nothing else. Now let's talk about e to the power sine of inverse log x. So you can write this as y equals to e to the power sine of inverse log x. Supposedly it is like this. So you can write, in place of log x, So you can write t, so you can write it as e to the power sine of inverse t. In place of sine of inverse t, you can write, say, what, s. So it is y equals to e to the power s. Okay, what is dy by ds? That is e to the power s. What is ds by dt? It is 1 upon root of 1 minus t square. What is dt by dx? It is 1 upon x. And in case if I want to find out what is dy by dx, it is basically the product of dy by ds into ds by dt into dt by dx, which is, what is dy by ds? E to the power s. What is ds by dt? 1 upon root of 1 minus t square into dt by dx is 1 upon x. Now, in place of t, you can basically write log of x. So it is 1 upon root of 1 minus log of x square into 1 upon x here. And here, again, in place of s, you can basically write sine of inverse t. But sine of inverse t, sine of inverse, in place of t, you can write again log of x. Okay, so this is your s. So s could be written as, now this entire thing could be written as e to the power sine of inverse log x into 1 upon x into root of 1 minus log x square. This is the derivative for this. Okay, then you have the third question which says sine of ex cube. So y equals to sine of e to the power x cube. So you can write x cube as, say, t. So this could be written as sine of e to the power t. You can write e to the power t as w. So this could be written as sine of w. And here w could be written as e to the power x cube. Okay, now this is there. Okay, so you can find out basically what is dw by dt, which is just e to the power t. You can find out what is dt by dx, which is 3x square. And you can also find out what is dy by dw, which is cos of w. So dy by dx is the product of dy by dw into dw by dt into dt by dx, which is equal to cos of w. dw by dt is e to the power t and dt by dx is 3x square. So cos of w could be written as cos of, in place of w you can write e to the power x cube, the way we have written it here. E to the power t could be written as w. Okay, e to the power t could be written as w, which is nothing but, sorry, in place of t you can write, sorry, ex cube into 3x square. So this is dy by dx in this case. Now supposedly if you have this question which is cos x upon 1 upon log x, cos x into 1 upon log x, so you have y equals to cos x into 1 upon log x. So what you can do is, supposedly if Well, I think this you can also solve it using quotient rule. So you can write it as log of x is t. So, and you can, I think you can straight away use just quotient rule here, or the product rule, whichever you want. So dy by dx is equal to first function as it is into derivative of the second function, which is 1 upon log x, plus second function as it is into derivative of the first function, which is derivative of cos x. Now you have to remember this, that what is the derivative of 1 upon log x? Okay, so you can write it as using the quotient rule, which is denominator square. So it is denominator into derivative of numerator minus numerator into derivative of denominator, which is minus 1 upon x log of x square. So in place of this you can write cos x into minus 1 upon x log x square plus 1 upon log x into minus sin x. Okay, the derivative of cos x is minus sin x, so you can write this as minus cos x upon x log x square minus sin x upon log x. Then one other question which we have here is y equals to sine of log x plus e to the power x plus cos x. Y equals to sine of log x plus e to the power x plus cos x. Okay, so you can write dy by dx as derivative of sine x, which is say cos of all this, into derivative of this in the parenthesis, which is d by dx of log x plus e to the power x plus cos x, which is cos of log x plus e to the power x plus cos x into 1 upon x plus e to the power x minus sin x. This is what you have. Okay, so these are some of the simple examples of exponential and logarithmic differentiation. In part 2 we'll pick up the logarithmic differentiation in detail.